Prior to using the T3, you must fully charge one of the batteries. To charge a battery, attach the proper power supply cord 110-volt AC or 12-volt DC to the charger base. The red LED on the front of the charger should flash red once to indicate that it is receiving power. Insert the battery so that the charging contacts are engaged. The LED on the front of the base will turn red and remain red during the charge process. Once the battery is fully charged, the LED will turn green. The charger base will switch to a trickle charge once the battery is fully charged, so it is not necessary to remove the battery until it is needed. Charging a fully drained battery should take approximately 90 minutes. If you have the optional alkaline battery pack, which is blue, do not place this in the charger. This can damage the charger, the alkaline batteries, and the battery pack. Once your battery is fully charged, insert it into the T3. Align the edges of the battery with the rails on the bottom of the imager, and slide the battery back until it is fully engaged. To release the battery, press both battery release buttons, which are located here, underneath the imager on each side. To activate the T3, place a fully charged battery into the imager and fully depress the gray on-off button. The LCD display will come on with the Bullard logo as the electronics warm up. After approximately 5 seconds, the display will show thermal images and be ready for use. The approximate battery level is indicated above the LCD using 3 green, 1 yellow, and 1 red LED. When the red LED is illuminated, the battery has about 5 minutes of operating time left. A fully charged battery should last about 2.5 hours. To turn off the T3, fully depress the gray on-off button again. The T3 is equipped with a shutter behind the lens. This shutter will activate every 30 seconds to 3 minutes depending on the environment. When the shutter is down, it blocks the infrared detector, allowing the imager to recalibrate itself and ensure the best picture possible. This image freeze will last less than 1 second, but firefighters should be aware that this is normal. The shutter will also activate each time the T3 goes into or out of EI mode. When the shutter fires, users must realize that they cannot continue to scan or search an area until the normal image returns on the LCD. EI mode indicates that the T3 has adjusted its sensitivity levels. All of the focus and gain controls of the T3 are automatic. However, when the imager detects high levels of heat, it adjusts its gain to provide the best image possible. In the high heat mode, an EI symbol will appear in the left corner of the display. The T3 will stay in EI mode as long as it is aimed at an object that is approximately 300 degrees Fahrenheit or hotter. Remember, the shutter will activate going into and coming out of EI mode. Therefore, there will be a slight image freeze on the display during the transition. On the right side of the display screen, your T3 has a bar graph. This is the relative heat indicator, or RHI. When the crosshairs in the center of the display are aimed at an object, the bar will fill in the RHI to indicate the approximate surface temperature of the object. Note that this is only an approximation of the surface temperature. There are a number of factors that affect the accuracy of the RHI, some of which are discussed in the next section. The RHI can be used to compare like objects, helping to determine which is warmer or cooler. On shiny surfaces, especially polished metals, the RHI will generally indicate an artificially low temperature or false cold. Note, the RHI does not estimate gas temperatures. Your T3 Max also has a special Red Hot feature. Red Hot is active only when the imager is in EI mode. Any surface temperature that the T3 Max calculates to be 1100 degrees Fahrenheit or hotter will be colored red on the display. Some superheated gases may show brief periods of red colorization. However, in general, the Red Hot feature will appear for surfaces over 1100 degrees. As with the RHI, there are a number of factors that can affect the accuracy of the red colorization and its activation at 1100 degrees. Keep in mind that because shiny surfaces and polished metals generally give false cold signals to the imager, these surfaces may be over 1100 degrees, even if they do not have red colorization.